Next we're going to test the system. We're going to use laptop 0 to ping PC 0 and PC 1, and if the static routing is correctly configured, we will have a route directly to each of the PCs as required, and they will have a route to reply back to us. I'll open up the command prompt and type ping 172.16.1.254, which is the IP address of PC 0. And I now have successful connections. If I do that again, we are now successfully routing between the laptop and PC 0. I'm now also going to ping to laptop or to PC 1, so 172.16.3.254, which is this PC here. And that is now routing successfully, as we can see. We can in fact view this using some of the additional tools within Packet Tracer. If I come over to this area and add a simple PDU, I can state that I want to have a look at that packet traveling from the laptop to the PC. I can go to my simulation mode. Next I'm going to edit the filters. What this will do is eliminate all of the packets which may be visible on the system and restrict our view just to ICMP packets. I can now move this out of the way, and I can capture and forward, in other words see this packet being moved to PC 1 and back. So we're routing to router 1 and we're routing to the PC, and it is then replying and successfully responding to our laptop. So in this case we've demonstrated that an ICMP packet will successfully be delivered to PC 1 and will be successfully routed back to our laptop. We will now add a second PDU from our laptop, and we will attempt to deliver that to PC 0. We will start our simulation and send packets to router 2, will now be delivered to router 1, as follows. Our second ICMP packet will be sent to PC 0, which will be successfully returned back to us, showing that we now have connectivity between the laptop and both of our PCs. This concludes part 1 of the Lab 5 for Networking 1. The second part of Lab 5 is to identify the route that packets will take in the event of a network outage. So what we're going to do is simulate the link between router 1 and PC 1 being disconnected or some other fault occurring. Just to show you what will happen to packets in this event, we will take a simple PDU and we will start it from laptop 0, and we will still attempt to contact PC 1. We'll run our simulation, again just ensuring that we are only looking at ICMP packets, and we will start as follows. Packet is sent to router 1. Unfortunately, router 1 at this point no longer has a route to PC 1, and that packet will be not delivered, and we will have a return which will explain that in fact we had a failure to route. Usually the errors that say that we have network destination unavailable. For the final part of this lab, we're going to demonstrate a routing loop, which is usually a badly configured or misconfigured network environment where we have packets destined for a network bouncing between routers and never actually reaching their destination. At this point we don't have a connection to PC 1, So as we've just seen, if we try and route between laptop 0 and PC 1, router 1 will correctly tell us that there is no route and will return the packet to us, and we'll understand that we can't actually reach that destination. If we incorrectly configured router 1 with a static route which did not show the connection going from router 1 directly over the fast Ethernet, but in fact redirected the packet to router 0, we can create a loop. And let's first of all have a look at our routing table. You see that we no longer have a route to go from 172.16.3. So I'm going to manually add one in, and just bear in mind that this is an incorrect configuration. So I set an IP route to 172.16.3.0, and I will send it back over this serial link here, which will be serial 0/0/0, sorry, 030. Now if we have a look at our routing table, it would now appear that router 1 can correctly access all of our 5 networks, but as we've just explained, the route to 172.16.3, it will route out the following interface. So let's just simulate what would happen if we were trying to contact PC 1 from laptop 0. I will configure a packet to be sent from laptop 0, and I will send it to PC 1. I will now start my simulation, move this down, and I will reset the simulation and do a capture forward. So our first packet is sent to router 2, which is correct. Next we're sent to router 1. Now in our previous scenario we were dropping the packets because we didn't have a route to PC 1. In this case we're saying the route to that network is in fact across this serial line. And as you can see, we're now routing across to router 0. Router 0 has a static route configured to send packets destined for the 172.16.3 back to router 1, but as we can now see, we have a packet which is indefinitely routing from one router to the other and never reaching its destination, demonstrating a very simple routing loop within our system. And that concludes this part of the lab.